Hello to all of my humans, cyborgs, robots, and especially extraterrestrials. It is I, Dead Program, broadcasting to you live from La Pipa in beautiful Asturias, España. And today we have all kinds of fun set up for you here with my very charming and erudite companion, Gopherbot. The first, well, actually, this is not the very first robotic programmable plushie. That was, it's kind of like, Captain Marvel. There's different, plushies that have been called upon to become the Gopherbot. There, I said it, the Gopherbot. That's what we should call it. All right, so I'm going to take my mask off very briefly. So, yes, it's been a very, very exciting week in the world of technology, especially in the world of TinyGo. Yes, you may have seen, but we have had a major new release of TinyGo this week. Pretty exciting. Over 2 months of dedicated effort from all of our fantastic contributors and team members and just wonderful, cool people. So this is our new website. Pretty substantial amount of work has gone into this new website, and we'll talk about that a bit later. Also, some of the other cool things going on in TinyGo with this new release. In the world of Earth to space news, really interesting kind of crossover. Google, a company, as you know, is very near and dear to my heart, as one of the companies that's helped out a lot with TinyGo and the creators of Go, the programming language. So Google has signed a deal with Starlink, the satellite internet service that I am eagerly awaiting be installed here in my secret headquarters in Spain. So Google is going to be providing exclusive data center connection to Starlink. Essentially, the Starlink terrestrial data centers will be the Google data centers. So it's interesting things happening there. We shall find out more as time goes on. So anyway, back to TinyGo. So yes, TinyGo, this week's announcement was greeted with quite a lot of acclaim, really amazing response. We're so grateful to so many awesome people who have been contributing both to the code as well as getting the word out. There's so many interesting things happening in this world of small programmable devices. So anyway, we redid the whole TinyGo website as a part of this release, but we have essentially a whole list of cool things that we've done. And I thought the easiest way would be just to bring up our list of the stuff that we sent out in the form of a tweet storm, Twitter thread, and we could just go through real quick some of the cool stuff that we've done. So first of all, you saw our new website. That's actually pretty interesting because one of the things about the new website is we've taken and we've revised our entire documentation system in a way that was first proposed by the people over at Divio. And if we take a look at their website at documentation.divio.com, that was the inspiration for us to redo all our documentation around this two-dimensional axes of tutorials, how-to guides, explanations, and reference. I'm not going to get too far into it, but this is a really amazing way to organize the information. They spent a lot of time sort of putting together a system for creating documentation and pretty impressive work. So naturally, we adopted it, and that's the system that we are using for the new documentation on the TinyGo website. So you may have noticed that the site itself is really cool looking. The reason for that is that we are using Doxy now. So Doxy is a very cool project from, it's not an official Google project, but it is created by people at Google. And it uses Hugo, which is the same static site generation tool that we were previously using, and a lot of people are using, really awesome tool. and it combines it with a bunch of templates and structure specific to creating documentation sites. So it was a lot of work for us, but substantially less because of all these amazing tools that we were able to make use of. So something that I thought was really interesting, I lost the link here, but so this week is actually, once again, in Europe, one of the craziest weather weeks. I'm not sure if I have it saved somewhere. Let me look and see if maybe I have it on my phone. So yeah, it's really like insanely crazy weather, and that brings up sort of the major issue that we have, kind of why do you need the Internet of Things? Well, one reason is because of things like this, which this is from the University of Southern California's meteorological department, and you can see that all the way from the Caribbean is coming this massive river of water heading directly to where I happen to be in northern Spain. So it's great when it rains, certainly, but if there's any place where we probably don't need a river in the sky to come, it is Asturias. Really, it's other places in Spain, especially the south of Spain, where water is an extremely precious commodity, and it's really crucial for the cultivation of those all-important crops, especially olives and olive oil and almonds. So more on that in future episodes, but as I work with a number of people, amateurs and professionals, on setting up my own automated farming system, all based on permaculture, that we're going to do some really interesting automation of that, and of course it'll all be open source. So more on that coming in future episodes. So anyway, though, last week we continued our extremely educational and fun Learning to TinyGo with friend Lorenzo, and he actually brought his computer, and I know he said he was going to do his homework. I'm going to put my mask on because we still haven't gotten vaccinated yet here, but we're waiting eagerly. We're too young to be in the vaccination group as I put on my mask. Yeah. So, hey, Lorenzo, how's it going? Let's turn on the main camera.
Hello.
So, welcome back.
Thank you.
So, yeah, I see you brought your computer with you this
Right.
week.
Yes.
I was making too much fun of you for not having done your homework to actually install TinyGo, and even have a whole new release that's come out since then.
Fantastic.
I don't know if you've.
I have to admit something. Well, we've been playing together with one of my friends here at La Pipa, and we've been challenging each other. So he was using a Linux laptop and me on my Windows. He succeeded at first attempt while I failed. I'm sorry.
Oh, well,
I guess we need some help from you in this case. So I had some troubles. I followed the instruction, but the serial port was kind of flapping, so it wasn't able at the end to flash the blinky one. Hello world example. And,
interesting.
Yeah, that was the problem. Yes, I could see the device, but it was kind of disappearing randomly, and to be honest, I don't know what could be the problem.
Well, we should take a look.
Yes, I have brought the same setup in here. So here we have the Arduino Nano 33 IoT, and I will plug it in.
Excellent. And we see
Well,
here you've got your Windows notebook.
Yeah.
That looks even newer than my Dell. Wait, Core i7 10th generation? Yeah, okay. Yeah.
I like this machine actually. It's kind of.
I have to say, I love this notebook.
Yes.
Dell has, made a really great notebook with this XPS 13, and I got the developer edition, which came with Ubuntu pre-installed. So, very, very cool. Barton George over at Dell has really been spearheading running Linux on Dell hardware out of the box, and amazing work.
I think this is a great move. Yes, I agree.
Unfortunately, though, it seems like we have ran into a little trouble here. So
Okay.
first of all, did you add TinyGo to your path?
Yeah, let's.
Maybe you want to enlarge your
yeah,
window and
absolutely.
also then enlarge
Sorry,
the font.
I usually work onto an external display, so TinyGo version, I guess. Maybe I have to set up the path again. It was not.
It seems
not
like it's
sure.
taking an awfully long time.
That's weird. So shall we?
Oh,
Okay. Yes.
Okay, well, it's the latest version, the 0.18 that we just released. Wow, cool.
Yeah, Bossack as well to Flash. I think Bossack help maybe will show. I'm not sure.
Yeah, I think if you just type the BOSSAC and
Or no, I have to set up the path. Probably is not.
that's really important to do. So you might want to.
Sorry, I don't remember.
So just as a quick overview, what are we actually trying to do here? And we can, while you're playing with that, we can go over to.
Yes.
So we are going through the workshop that was first introduced at GopherCon 2019 and has been done several times since then for an Arduino sensor station using the Arduino Nano 33 IoT. And so in order to flash that particular board, we have to use a command line tool called Bossack, which is one of the tools that is created specifically for this bootloader, which is on the AT SAM D21 and D51. I think it's actually from Microchip. They're the creators of it. Anyway, so you need to use this BOSSA command line utility, and it does work on Windows, apparently, even though we don't have instructions here for that, but supposedly it does. I have not used it. Actually, no, I think I did use it while testing.
Wait, sorry.
So let's go jump over here and see how Lorenzo is doing.
Okay, I have to set up the environment.
Is it Bossack or Bossa?
Maybe it's Bossa. No?
No, neither one. So what is your path?
Okay. Eco.
I think if we say,
I don't remember hearing.
Yeah,
Windows.
dollar
It's
sign
dollar.
path.
It's on on Linux, but on
I think on it is also.
no, or we. I don't remember. It's a long time. No.
Maybe it's no, it's maybe in parentheses.
Print. Eco. And
Path, Windows.
Vars Windows. Let's see. Having display the control environment. Sorry.
No, I think it's maybe two parentheses.
Okay, yes, two of those. Yeah. Yeah, that's the one, and probably Bossack should be.
It may or may not actually be in there.
It should, I guess, because we added. Okay. Set path, program file, bosses should be in here.
That's one way to do it. I usually just go and change it permanently because.
Okay, let's go into the. 1 second.
Well, you could test it first just to see if it actually worked.
Let me see, maybe in here, right? Start open recording, environment bars, path, edit. Maybe you can add it in here, new, and I'll paste what we. Sorry,
No, it's quite all right. I think, yeah, exactly. You just need to get rid of the extra characters.
Yes, and I guess maybe I hope I don't have to restart the machine, but I guess it should work like this if you just restart the prompt here and CMD and.
So now you should be able to just type Bossa.
Okay, Bossa. Oi. Yeah, done.
So that's what comes up. Or it might be Bossa C actually, because
Okay, this is the
on I think Bossa might be the
installer or the client.
yeah
thingy.
the GUI client.
Bossack. Then
Yes, exactly.
yeah.
Bossack dash H.
Okay. Let's see.
It means dash, not forward slash. It's really.
Okay.
I know you think
Oh
you're
no,
on.
no, I have another keyboard here.
You think you're on Windows, and now
Yeah,
it's
no,
going
I
to.
used to use an external keyboard, so I have to use the Spanish one. And now we have it.
Okay.
Okay. Big
So
screen,
now you should be able to Tiny Go version again.
Tiny Go version
Okay.
018.
So now we should be able to see, well, we could see Tiny Go and we could see Bossack. So we should now, in theory, be able to flash it. So in order to do that, we have to,
Well, I can show you the ports and let's see what
well, I don't know if it'll show up on a port
onto the.
because I'm not sure if it will or not.
Let me. 1 second. I was.
I think that if you don't enter a port, it will find a port.
Okay. Okay. You don't have to specify.
I don't believe so. So I think if you
Hmm.
just, were to go back to the terminal,
Okay.
and if you were to type TinyGo space flash
And we have to specify the
dash
platform,
target,
target, which is Arduino. It's
Arduino
dash
dash Nano 33,
And I forgot here.
and then we just can type examples. You don't need to specify a path because but without a path, it will assume that you mean the examples directory in the TinyGo source itself.
Yeah, but then I have to move
So
within.
You don't have to. It'll work. So if you just type examples / or I guess maybe
No,
backslash.
not from here.
Yeah, no, it'll work. If you just type examples,
Exact.
examples, AMPELS, and then I guess backslash,
Backslash. This key.
where,
this keyboard
wherever that is.
Here.
I know, there's a backslash somewhere.
Yeah.
And then Blinky1.
Blinky one.
I
But
think that's it.
it doesn't pick it. .go or something?
No.
Will it look for the remote repo or no?
No, we'll look for the TinyGo installation directory into its source in order to find the examples directory just as a default.
Okay.
That I'm not sure if it's the most, how do I say, intuitive feature.
I cloned the repo, so maybe if we switch to that directory.
It shouldn't matter
Okay.
because it uses the.
No
Okay, so now, so we see no serial
port
port available.
here because I think it's we can see on device. Sorry. Where are you? COM ports. That's the thing. Sometimes it shows and sometimes not. I think we have to double reset here. Click twice onto the reset button to make. You see, we can try now, but let's see how it behaves. It just, you see, we have a different error message this time. And look at that. Probably
And then where did you download Bossack from?
Well, I think I went onto the TinyGo. I was following the instructions step by step, so.
I'm just wondering where did this.
In which location on the drive?
No, I mean where did you obtain the download for the Windows version of Bossa?
Let me go there because it's on the TinyGo page.
I believe you.
Yep.
I'm just wondering myself.
So let me flashing boards. Let's find Bossa. Okay. GitHub. This one, Shumatech Bossa released, and that's
Okay,
the one.
no, that should have been it.
Yeah. One thing, probably we could repeat the installation. What do you think? Shall we?
I don't think you will need to.
Okay.
Probably. That's interesting that it's complaining about an extra.
But if I show you here, let me do a refresh and see if the port. Because the problem I had was that it just disappeared. Maybe it's the COM4 or something like that, the default port, or it should scan any available. I disabled.
So the TinyGo will scan for serial ports, and it will pick any USB port, whichever the first one is, and if there's more than one, it'll
So
say,
that should be this.
yeah, but that wasn't the error you got. You got a different error. The error you got was an extra command in BASA. It had nothing to do with the port. The port is not working. We can see.
Okay, I see what your point. Yeah.
So yeah, the port was available, but then it hit this other problem, which was extra arguments found. So that makes me, let's see, we should go BASAC-V, I think.
Gosh, it's...
No, it's, oh wait, no, it should have shown that version. Yeah, there's 191. And we used offset. That's very, very interesting. I wonder, that was not a problem I'd seen before. So let's see if there's anything on the TinyGo website for if we look in the reference section, under microcontrollers, then we will find the Nano 33 IoT, and let's see if we have any interesting you must install into, did you install into C program files?
Let me have a look. I think...
The installer has an error in it.
Okay, so we do have here...
The BOSAC installer.
That's the one, BOSAC.
And you have to take a look to make sure...
Yeah, it's in BOSA program files.
Not program files 64 or whatever.
No, that's it. And here where is the two executables.
Okay, so and it looks like it should have, that should have been okay.
Yes.
Okay, so, oh, wait, we can go back to your screen. So yeah, so it seemed like it found it okay. So one thing that we can try to do here is, so we should have been able to, I have not tried flashing from Windows onto using BOSAC myself in a while. So so there may be something that's a regression bug that, I mean, the problem is not the serial port at all.
No, okay.
The problem is something to do with the command line that's being, because BOSAC, what's happening here is TinyGo needs to use some tool to do the flashing.
Okay.
So some of the platforms, we don't need a separate tool because, for example, with the UF2 bootloader, all we have to do is create the UF2 file and copy it to the mass storage device, similar to the way that some of the STM32 boards work that use the J-Link. You could just copy a new file onto the mass storage device and it loads the new program and reboots the device. On normal Arduinos, you do this with AVRDude.
Yes.
Right? So you create the binary somehow, and then you have to get that binary onto the device. So Arduino uses AVRDude to flash these AVR processors. So in similar fashion with the BOSAC bootloader, we need to flash it using a flashing tool, and that flashing tool is this BOSAC tool. And that's why TinyGo has to ask you to download and install it separately. So obviously it's in your path, or else it wouldn't have given you this error message about extra arguments found, but it didn't tell you which those extra arguments actually were. So, so how to diagnose that could be, for example,
is it possible it does not recognize this platform, Arduino Nano 33, and we have to do some pre-work, or it's...
No, because that target that's part of TinyGo itself.
Okay.
And this is just saying, you compile the program for, whoops, I forgot. Windows really likes to copy or to paste. This is saying, compile the program for this target processor, or board rather, and then use whatever flashing tool is configured for this type of board.
Okay.
In this case, it uses the BOSAC. So that if you were to look in the TinyGo source, you would actually see, interestingly, that we have, is this really the thing we want to do right now? Well, sure. So the TinyGo source itself has the ability to flash many different boards using many different types of binaries. It could be hex, ELF, bin, or UF2. And then depending on whether we're using a command to flash with, for example, BOSAC or AVR Dude, or a mass storage device where we could just copy it on there, or OpenOCD, in the case that we want to use OpenOCD to do our work for us, like if we want to run it in a debugger. So it's very flexible, but in this particular case, it would appear that there's some command flag difference suddenly that was not being passed for the Windows version, where we can do the same thing on Linux without a problem using the same version of TinyGo, because we are, let's make sure I'm using, oh no, I have the dev version. Let's git checkout release. Let's see. So update our submodule. I just want to install the same version you have. I've already got the next version installed.
Okay.
Yeah, we move quick. But the one solution that we can do here in order to get past this problem for you is you can build your program and then flash it separately just by using BOSAC. So if you do, go back to your command line here, and can you make the screen a little larger?
Let me...
Because it's really small.
Yeah, you're right. Hold on a second, because I don't remember how to do that, but probably it's in... Oh, where is it? Sorry.
Oh, no worries.
Okay. I think it's somewhere. Edit, properties, and fonts. I guess this is the way to go in here. I think this is very nice.
Oh, that's much better. I can see a lot better now.
Sorry.
Okay, no worries. All right.
I had the same problem, but I didn't want to say
So
it.
now you want to change directories to wherever you've got your code.
Okay.
Do you have a place for
yes,
the code? Yes.
I do. Docs, where is the backslash? Projects and tiny go. And here I guess we have the repo tiny go. This is the clone. Yeah, that should be.
Okay. Well.
We can move somewhere else and start from scratch if you like.
Well, no, I think you got the right idea there, but what you probably want to do is download the repository, which is where the workshop stuff is, which is, and that way
I see your point. Yes, absolutely.
we can kind of work from there.
Git.
Of course, I think I need to update this one little thing that we discovered. Let's see. Because I realized there was no mod file, so it couldn't install the correct modules. So let's just say commit Arduino, add mod file to project. Okay, so okay, so now we pushed it up there. So now if you go to you could just bring up a web browser is the easiest way.
Okay, so.
Oh no, you could do it with git clone. I didn't realize you already were there. So I think it's HTTPS :
Okay.
GitHub.com.
Okay.
You got an extra U in there. This is why I copy and paste.
Oh yes. I do the same, but in this case.
And then / hybrid group, all one word. And then / GopherCon, GOPHERCON dash 2019 .git.
Okay.
That should work. Hopefully.
Yep, it's working. Resolving dense remote compressive.
Okay, so now if you change directories into the GopherCon 2019,
Go.
and then you change directories into, I believe, sensor,
Oui.
and then change directory into Arduino. Okay, so now we should be able to, because of our Go modules file, we should be able to say tinygo space, we could just try build
Okay.
space -O for output, and then we'll name it, I guess, step 0
Oui.
.bin,
Okay.
and then space, and then dot, I guess, backslash,
Without a space,
yeah, dot,
it says, okay,
dot,
yeah.
backslash step 0, and that should be it.
Okay, let's.
Oh wait, we need a target. Sorry.
Okay.
So add after the output or before the output, it doesn't matter. In other words, before the -O flag
Okay,
or
sorry,
after.
Yes.
But before the flag though. Like you can't.
Okay, sorry. Before
don't
the-
override that exactly.
okay,
So
sorry.
dash target. You need dash target because it's a flag. Not sorry. Let's go back. Put
okay,
a dash in front of the word
Yeah,
target.
I see. It's a.
Sorry.
It's a. Yeah,
It's a flag, yeah.
Yeah, it's a flag.
And
yeah.
then for the target, we will say Arduino-Nano 33. Not because you have two words target. There you go.
Arduino/Nano 33.
Exactly.
Okay, sorry.
No worries. Okay, so that should, in theory, compile it. Okay, it did. So now we should be able to try to flash it by using the BOSAC command, which we're going to have to look up the full syntax, because if you don't do this right, you will brick your board.
You cannot recover it once you.
Not without a J-Link and
Okay.
some pogo pad pins and a real. I haven't done it yet successfully, just because I'm lacking the right pins to connect. I have everything I need except for the pins to connect to the bottom side of the board. So it's like BOSAC, Flash, Arduino, Nano 33 IoT, something like that. And let's see. I could probably find it if I just look for TinyGo, and I find like an older version of this. This was a, let's see. Let's see. That wasn't it. This is close to it, but let's see. I don't know the fastest way for me to send this to you, but we could just try typing it, I guess.
Yeah.
So the most important thing is that you don't forget output or offset. So just type BOSAC-H. No, BOSAC just -H.
Okay. Dash H.
So we can see, yeah, that's it. So we can see all the options. Okay. So now we want to say BOSAC space, and then I'll start telling you parameters. So let's look and see what we have. -I
Which stands
for info,
Okay.
display device info,
I
and then -E
E.
for erase, space, and then -W for write,
All of that at the same.
No, don't type, don't hit
ah.
anything yet. I'm just,
Okay. So, okay, the ones to investigate first.
right, I'm looking to see the offset because, oh, wait, actually, Adafruit might have info on this. Let's see. Because it's really important to include the right command. So if there's this, if you have to use this offset, dash offset, I think it's hex 2000. Hold on. Yeah, here we go. So this is what it's going to be.
Okay.
So,
P.
dash P, and then I think it was COM 11.
Let me double check just to make sure we. Oh, I closed the. Not sure. Hey, sorry.
No worries.
Okay. 10.
COM 10. Okay, very
10.
good.
Okay, COM 10.
COM 10. And then
Minus
dash
E.
E for erase.
Dash E. Dash.
Then dash W for write.
W. Dash V.
Dash V for verify.
Dash R.
Dash capital uppercase R.
And
Then dash offset equals OX 2000.
0x.
So hex 2000. That's really important, or else that's when you brick it.
Okay.
And then wherever the bin file is.
Oh,
That's
sorry.
which is in your current directory, whatever you
yeah,
called it. Step 0 dot bin or something.
It should pick it up.
Dot bin.
Dot bin. Wait, why is not? Oh yeah.
All right. That
Something
looks,
else.
that looks about right.
Double, triple check. I think it's good. And offset is 0x 2000.
Okay.
So I go.
We'll see what happens.
Erase flash. Yeah.
Okay. And look,
Looks fantastic.
it's actually blinking.
Wow.
So there must be a difference in the latest version of TinyGo that is added some extra parameter or something, or maybe there's a problem with one of the parameters. We'll have to look into that. But that was working.
Perfect.
So now though, you know the way to get around it, which is to build it and then flash it, which is the same thing that the TinyGo flash command does.
I see.
Okay,
The hard way.
yeah, this is, flashing the hard way. But now you see why we work on the TinyGo flash command to try to avoid you needing to know all this information. But apparently there is a new problem that was introduced with the Windows version when flashing the board, because it was saying that there was an extra parameter, and it didn't actually tell us which parameter it was. If we were using the dash debug flag, then we could probably figure that out. But we should probably report that upstream, right? Just because that's not good. So if you wanted to go and enter a GitHub issue to go to the TinyGo repo and enter in the new issue saying, I just tried to flash with Windows, you don't have to do it right this instant. But that way we don't forget that we need to look into that, because that was working and now it's not.
Great. I will.
Okay. So so now let's go to the actual task that we were trying to do, which was to go and do step 2,
Okay.
right? Because if you go back to the web page, you never actually opened the web page
Not
for the
today.
repo
No. Not
with
today.
the GopherCon 2019, just because that would be a little easier to.
Go.
So-
Con.
Well, no, it's it's the same repo you just cloned.
Okay.
So github.com.
Should be
Well,
somewhere. It's
all of that, but without the Git part.
okay. So I should go onto the web page of. Sorry.
Exactly. Go to that web page. I know, he's like, how do I copy on
I'm not
Windows?
sure does it work because
It's like a
yeah,
it's
yeah.
like a weird, like you have to hit the enter key or something, which to me is very
dangerous.
non-intuitive. Like I really don't want to hit the enter key right now. I want to copy this, not execute the erase all disk kind of thing. So anyway, if you click on Sensor Arduino, that's what we're actually doing right now, right?
I also have switched the right and left key, so I'm.
So if you go and you take a look at the instructions, if you just scroll down a bit, keep going, keep going. This is all the setup we already did. This is showing you the pins, how to run the code. We did step 0, the built-in LED, right? Step 1 we did with the blue LED, which I see you disconnected.
Yeah, you're right. We did it.
Right, that was what we did last time.
Yes.
So now we're on step 2, which is a button and an LED.
Okay.
So now we need to get your parts out.
Button. I will look for it.
Button. Who's got the button? I only give one of these out per person, just because otherwise you're like, dear programmer, I lost my whole kit. Can I have another one? I'm like, oh, really? Do you just need another one for your friend? It's like, yes. Are you your friend? Yes. Okay, here's another kit. Well, I mean, if I can. It's been a while since I got to do one of these in-person workshops, and it is always a good time had by everybody, especially me. If I ever got to indulge my Santa Claus complex, it is during these workshops. You get to give away so much awesome stuff. It is so fun. It's just amazing. Actually, the last time we got to do this was at FOSDEM. Not FOSDEM. It was actually at Scale. And the last Scale before the pandemic. That was really fun. Okay, looks like we found, because we need the LED and the button. Do you have the LED?
I think it's the blue one, right?
I think it should be attached to your breadboard.
Oh, you're right. That's why.
That's why we did this. So if we take a look here at the...
Shall we move on to the other camera, or no? It's fine here.
Oh, no, yeah, actually, I think you're right. I think you're absolutely right. We should. And let's turn on the... and we can get a little focus going.
Light. So here we have the small... It's hard to see, but I think this is the way.
Yeah, that's the button.
Yeah.
And then show us the other parts.
And we have a breadboard and a separate blue LED.
Cool. So now your cable is very short.
Ouch.
If it had only been longer, but that's okay. We'll just go back to the other camera, view,
Okay.
because that way we got the close up.
Let me have a look. Yes, it's enough. Why?
Yeah, that's good enough. Exactly. So now continuing on to step 2, the blue LED and the button.
Okay, so we have here these two components, cables enough, and should I read here? And
It looks like you disconnected a few of the cables from before.
I'm afraid that yes. I mean, there is power, but it's not coming from the board. So I guess we should start by connecting ground and positive, which these are the ones.
That's right.
To the, can you see the, I don't know, with the camera, I will do it in here. Let me see. So we take the positive pin, plug it into the positive rail here in the board, and the negative one, and here we have power. I don't know if you can see the setup.
Yeah, that looks good.
Okay.
So now we just need to actually plug in the pins on the LED to the correct pins.
It's the control one, because we have power, but I think the yellow one, it should be the, was it 12?
So if you go back to step 1,
Okay.
I don't remember. That's why I write these things down. You think I can remember these?
Absolutely.
Was it pin 1 or pin 11? I don't know. In the heat of battle, I forgot myself. What could go wrong?
3, D12.
Okay,
So it's
D12.
digital output 12. Do you have?
So yeah, if you scroll up on this page, you see that we have the.
Oh, so if we put the board like that, it's the uppermost left pin.
Yes.
We have the digital output we are looking for, D12. Let me plug this one in here. If I'm not seeing, and
Looks like it's one over.
but it looks like it's missing.
Yes, it's
some-
one over because the last pin.
Ah, okay, I see.
Yeah, it's not actually plugged into anything.
Ah,
I probably should have moved it over just a little bit further, so that was not the case. I suddenly
no,
realized
no.
that.
Let me tell you, yeah, we also lost the positive.
You can never lose the positive, man.
No. But still we don't have anything.
Well, yeah, because
We didn't flash the one that was
Exactly.
to-
we did not flash the correct code.
Yes.
Precisely. Excellent.
Okay. So we are going to flash the
So we have to.
step
so,
one.
Exactly.
Okay.
So go back to your terminal,
Mm,
and you want to build it first.
good. It's a good reminder.
I know, where would I be without my
I
bash
will
history?
Go build.
And so it's step one.
Let's go from here. Step
That's a good
One.
idea.
and wait. Step one. Dot. No, bin is in there. Onto the same path. Okay, I go. Huh?
Yeah, so it's going to build into a step one dot
Building
bin.
Windows Screen not supported.
Oh, because you need the target.
Uh,
So hit up arrow, and then left over, right before the dash. We forgot that. So it's after the build command, but before the dash O
Okay.
flag.
Target Arduino dash Nano 33.
Now take a look at the error message that it told you.
Building Windows binary is currently not supported. A specific different target, which is what was.
This was
mentioned.
a contribution from one of our awesome users in the last iteration. I can't remember who did it, but this is to basically, since we can't actually build a binary that executes on Windows currently, you can cross-compile from Windows to like your Arduino, but you can't build a Windows executable
Okay.
yet.
Yeah.
And so this is a message to tell you that you have to specify, you can run TinyGo on Windows to compile for your Arduino, but not, or for WebAssembly, but not for Windows itself.
Okay. So I will go with that.
Yep, looks good.
And yes.
Okay, so what's the last step?
Build, we have to flash it.
Correct, we
Yeah.
have to flash it.
Alrighty.
And oh, there it is.
And I think, well, step one
Yes,
and everything else, it's the same.
yes, that's correct.
No device.
So now the
we-
reason-
we probably have to rediscover the.
Well, no, on this case,
You see, now it's 11.
yeah,
So
Windows
we can
is
try
not,
11 and see if we.
it'll probably work, but it'll probably keep increasing.
Let me see. No, you're right. Why, how did you know that?
Just a bad feeling, but it should have, but it should have worked.
Let's try again. Or if you want, I can reset.
Yeah, we might need to do that, but
Let's have
Let's-
another
let's try again just to be sure.
stamp synchronize. No.
All right, well, I guess we do need to
Double.
double click the button to put it in bootloader mode, but it doesn't look like it worked. There you go.
Now, yes. Let's see what ports. So if we omit the port, it does no. You see now it's 10. Let's try again.
Apparently, it really wants port 10.
Erase flash. Yeah, this time it's working.
Okay, but I don't see the LED blinking.
Okay. Step one. Well, signal, power. Well, let's see if the power is actually. Yeah. No, it was on the right.
Oh.
It's an offset.
I just can't see very well,
yeah,
and
it's
kind of dark.
difficult.
Okay, all right. So now step 2 for us to be able to say, yes, we've
Shall we show this
carefully
one here
so it
that
doesn't
is-
fall apart. Here, let's go to the,
just to
Um,
see the setup, how we have everything connected, and there is some overexposure over here, but it's working.
all right. So now
So-
step 2, the actual step 2.
Okay. Step 1, it's done. Step 2, blue LED and button. So we have to plug the Grove button into a provided cable with the groove connector on one end and the male jumpers on the other, connected black mail, blah blah. Ground rail, the black mail.
So you need
Cable,
the cables.
cable.
Of which you have a collection of these cables, which are adapters from Grove connectors to
It's a-
DuPont connectors.
It's a good idea. I didn't knew that, but it's even easier now with this kind of. You don't have to think about which way, at least on the side of this. How do you call those boards with components? They have a name. Anyway, doesn't matter. So we
Okay.
know that power. It's the black one. We put into the ground. Ground is here in blue, so we have, I guess, this one connected. Now the black mail end to the breadboard, ground rail, done. Connect the red mail on the Grove cable to the breadboard power rail. So red mail, it's this one, to the breadboard power, and it's going here onto the red thing.
Mm-hmm.
So we have two. I think there is one. The yellow male end of the to cable pin D11. Well, we double check, although I have a suspicion where it's located. And it's on the left of D12. So I guess we can plug the yellow male to D12, which is just next to D11, which is just next to D12. And I guess do you agree, or
Yeah,
do you see anything?
you got your button, you got your LED. They're both plugged in to what look like the correct pins. So seems like okay. So you should be able to now
Do the same for step 2.
do exactly. So let's take a look at the code though, real
Yeah,
quick,
Good idea, much better.
before we go on to actually flash it. So this code is really similar to the code that we've been, and you may notice we just add more to each. It's the same program, but we add more to it. So package main,
Yes.
same as before. We're importing the machine and the time package,
As before.
same as before. Our function main,
Hmm.
so we declare our LED on pin D12
As output pin.
as an output pin. And then we have our button on pin D11
Yes,
as an input pin.
that's the different thing.
And so now our forever loop, the first thing we do is we say if not button get, meaning if we try to get the value of the button and it's off. The reason for this is that this pin is reversed. It's what you would call pulled up instead of down,
Okay,
meaning it's normally on, and when we push it, we turn it off.
I see. Okay.
So there is a way for us to reverse that, but in order to keep it as simple as possible, we just say if it's not get, then turn the LED low or off. Otherwise, turn the LED high or on, and then sleep for 10 milliseconds to give the system a chance to do something else,
Okay.
whatever that might be. The system in this case being the microcontroller. So now if we go back to flashing this,
Okay.
so you have to build it first, right?
build it first. Step 2.
Mm-hmm.
Okay, and now we I'll have a look just to see if anything has changed in the meanwhile. Yes, maybe we'll do another reset.
So what I think it is, this is what I think is happening. I think that when it's in the bootloader, it connects to COM10.
and it
And I think that when
locks.
it's running the normal, it connects to COM11.
Okay.
So Windows is creating two different COM ports. So that's the problem here when you specify the port to flash, is that that port isn't showing up yet. Like you have to reset a different port than what you're flashing on,
Okay.
just because of like how Windows is working. So I mean, the easiest way is obviously just to double tap the button, but it's not the most convenient.
Okay. Let's see.
But if you double tap, it should switch to 10.
and it did it.
That's because it's got a different vendor ID and product ID, and so Windows thinks it's a different device and puts it on a different COM port. It thinks you unplugged one and plugged in the other.
Okay.
You kind of did that, just
And now we have to flash it.
exactly. And step 2.
There is no. And yep, it's
Okay.
working.
So
Let-
now,
let-
how do you know if it's actually working? You have
Now-
you have to click on the button.
to see if we
Doesn't seem like it's actually doing its. Oh, it looks like the power cable came on.
disconnected. Yeah, that shouldn't
A little
matter
bit.
as far as we can plug it.
And
again.
also the ground.
Sorry, it's a bit of a mess in here
Yeah.
with cables. Next time we will try to get it more tidy. And yep, it does. So if I keep it pressed, it stays on, and as soon as I release this one, fantastic.
We can move it a little closer.
So I push the button, and yep,
All right. Amazing.
quite
You have input and output.
fantastic.
Okay, so now your homework this time is to organize your cables
Yeah,
so that
well-
when we go to step 3, we start plugging in more and more devices. Eventually, there's going to be a lot of things plugged in here.
Yeah, it's going to grow quickly, 1% a day, each week.
Cool, exactly. All right, well,
okay, thank you
thank
very
you
much.
very
Ron.
much.
It's been a pleasure. It's been
yeah, no, this has been awesome.
Bye. Ciao.
Yeah, you might want to take your stuff with you
Yes, yes.
because you got to
It's much
practice this.
better.
You got to
Exactly.
practice this at
I
home.
think I can unplug this with no issues.
I'm pretty sure.
Yeah. Okay. No atomic mushrooms.
No,
anywhere.
not yet.
Ciao, Ron. Thank
Ciao.
you.
That was fun. Yeah, we don't forget to report the problem on Windows that you ran into.
Yes.
That was unexpected. Well, most of the time I think we use Adafruit boards, really typically. Like we use these as, Adafruit boards from Windows, but we generally, I can take off the mask now because I'm alone. I'm alone at last. So yeah, usually we test these things on Linux or Macs. On Windows, a lot of people have Adafruit boards that use the mass storage device capabilities of the UF2 bootloader. So they don't run into that particular problem, but that's really good to know, and we definitely want to fix that. So yeah, the Arduino Nano 33 IoT, though, is a very cool board. And one of the things about it that I personally find so appealing is that it has built-in Wi-Fi. So we took a look at this before, but we didn't really get too into it. So the Nano 33 board has its main microcontroller, which is this. Oh, if we turn it around, we can actually see. We can maybe even read the print. Read the fine print. Almost. Wait. If I can just dial in the angle. There we go. Yeah, so you can see it's an Atmel. Got a little speck of something on there. So it's an Atmel AT-SAM D21. That's the main processor here. And then right next to it, it has a uBlocks Nina, which is a licensed version of the ExpressIF ESP32. So this is the board that's actually used for the coprocessor that's used for Wi-Fi communication, and this is the main processor that, does all the work, essentially. So we were doing quite a bit of work on TinyGo for this recent release, and one of the things that we had discovered was that there were some problems with the TinyGo driver for what is known as the Wi-Fi Nina. So Wi-Fi Nina is the name for the driver for what is using the Nina FW firmware, which is created by Arduino in order to provide an interface between the Wi-Fi capabilities that are on board the Nina 102 chip and whatever board you happen to be programming your application on. In this case, an Arduino Nano 33 IoT. So it turned out that there was a problem with this. They updated the firmware, and as a result, the driver was no longer working. And so we had a tremendous group effort, like 3 or 4 different people jumped all in at different times, and then finally right before this release, it all came together. So now we have a fully functional set of code on the Wi-Fi Nina driver. So I was actually just testing some of that before, and let me go back to, let me switch over to the dev version of TinyGo. So if I go to git checkout dev, and I want to git pull rebase origin dev, actually git reset hard, because I have some changes that I didn't actually want to keep. And so if we git pull rebase origin dev, pull in the latest code. Okay, good, we're on that. So now we type make. So we build the latest TinyGo version binary for our testing. And then go over to the drivers repo while we're doing that. Make sure that also using the latest dev drivers, which have been updated for changes subsequent to the release. So that's why we have to do this. And so let's go back to the build for TinyGo. I'll just copy the binary into my Go path and then rebuild my files that are used for generating the device files, which are used automatically built to create a wrapper between the Go language and the actual registers that are on the chip itself. Just actually a quick explanation on that. Let me see if I have it open somewhere. No. Well, it's okay. No biggie. Not that important. Well, it's still building. I was actually working on a diagram to kind of show the relationship between the different packages that are part of TinyGo. We can actually take a look at it in my local development environment. If we take a look at the documentation concept section, I was adding this diagram kind of showing how your program interacts with the main parts of TinyGo, which is your main package communicating with standard Go packages and the TinyGo runtime, which will then use the machine package, our hardware abstraction layer, to communicate with these device packages that I was just generating to then talk to the actual hardware. So the low-level wrappers in the device package, the hardware abstraction layer in the machine package, the TinyGo runtime so that Go can run on very small machines, your normal standard Go packages, and your main Go program. So just thought I would try to explain that a little better. Anyway, so back to, we've installed the new TinyGo. Let's run TinyGo version, and you'll see it's 0.19 dev. So Yes, it is the latest dev version. Okay, so now let's go back to our drivers repo, and I was just going to show you how, in fact, we can use the Wi-Fi drivers to communicate with devices using the Wi-Fi Nina. So, so this Wi-Fi Nina driver, once it's been installed on the firmware, which I've already done on this particular board that I'm going to use, and we can go take a look at some of the examples that we have. And so these actually are pretty cool. If we look under Wi-Fi Nina, we see there's actually several different ones. Sort of the simplest of them all is this Connect example, which what it does is it will connect to the device, which is the Wi-Fi Nina, using the TinyGo driver for it. It will use the SPI interface to communicate between the chip, the main microcontroller, and the Wi-Fi chip, and then configure that adapter. And then what we do is we connect to the access point, because we have to do that for any Wi-Fi device, right? We have to connect to whatever access point that device is going to use if it's in infrastructure mode, unless it is an access point, in which case it's waiting for devices to connect to it. But in this case, it's a client device like your notebook or your phone. So we have to connect to the AP, which the way that happens is we use commands that are built into the Wi-Fi adapter, and we try to connect to it. And if we are connected, then we can return on and actually do the work that we were trying to do, which in this case is just display some info about the MAC address, the IP address, and the current time. So let's see if this actually works. So if I look at my code, somewhere in one of these, there we go. And so if we go and we take a look at our Connect example on the Wi-Fi Nina, and this is the same code that we were just looking at. So we're going to have actually we'll go into the micro. So we're going to plug in the chip by using a cable. It's a little foggy, a little blurry. There we go. All right, so we'll plug it into my computer so I can flash it. I will not have these complications for flashing simply because I am using Linux, and Linux is usually a little more reliable for certain types of activities like hardware development in particular. Oh, wait, wrong cable. I need the USB-C to USB micro. There we go. All right, so we'll plug that in, plug it into my computer. All right, and then we will have to make sure that the I'm trying to remember. No, so embarrassing. Let's see. I think it's like something like that. Let's see here. So, all right. So let's go and try and flash this. And so if we go to my command line, I need to go flash. We'll say our target is the Arduino Nano 33. And we're going to flash examples, Wi-Fi Nina Connect. And so it should compile, and then it should flash my program. And so now if I go over to my serial, we should be able to see it's trying to connect to the Hackspace SSID, and I think I may have typed in the wrong username or password because it disconnected me. I know, so embarrassing, right? I can't even remember my own password. Well, let's see here. I really should write this down. Don't you think? How embarrassing. Someone's going to have to whisper the password in my ear again. That's really funny. Psst. What's the password?
Sorry.
Don't say it out loud.
Yeah, you were telling me something. Uppercase 2020. But I don't remember if the app is before the 2020.
I think it maybe it's...
I'll have a look.
Okay.
Sorry.
So we're trying to find out what's the actual password. We're so secure here that we don't even know how to log into our own devices. So embarrassing. So yeah, that's pretty funny. But that's how we know that it was, we switch back to, so it was trying to connect to the Hackspace SSID. It scans for a while before that SSID appears, and then it tried to connect and failed because it disconnected because I entered in the wrong password, apparently. So that's pretty embarrassing. Let's see if I can take a look and... I should have written it down. I do have it written down somewhere. I just can't remember where. Yeah, someone's trying to tell me the password here. I'll be right back. I know, it's really embarrassing. Every week I forget this password because it's really secure. It's so secure, I can't even get into it myself. It's pretty funny. I think it was... I don't remember. Anyway, but let's take a look at what the actual code is, just so we can familiarize ourselves a little bit with it while they try to find the password for me. So what's going to happen here is we're going to connect to the access point through connect to AP. Then we're going to print a line. We're going to check out whatever the IP address is for the one that we've been assigned on our Arduino Nano IoT device. We're going to print the time. In this case, it should be printing the time that's coming from the access point. And then we're going to print the MAC address, which is the MAC address, the built-in MAC address of the Arduino itself, right? Of the chip that's on board. Ah, okay, there we go. Yes, no wonder. It was a very complicated password, so complicated that I could not actually figure it out. That's really funny. Okay, so I guess we'll try again. That's really, really funny. All right, so let's try to flash this again, this time with the right information. So it's going to erase, it'll flash. Then we go to our terminal interface, and this time it should be able to connect. Yes. Okay, so we see it connected, and it displayed the IP address that the Arduino was assigned, the subnet, the gateway address of the router, the time, which apparently has never been set. It's still the beginning of Unix time. And then the MAC address of the board itself. Okay? So, doesn't do that much. But let's go take a look at another one of the examples. That way we can kind of get a slightly more complete idea about some of the capabilities. So one of the ways that it's usually very good to, let's just try the web client. So what does the web client do? So the web client is going to open a TCP connection, an actual network connection, to the TinyGo website, and then it's going to fetch down by making an HTTP request. It's going to fetch down the home page. Now, it's not going to have any way to actually display that because it's a text-only device, but it will be able to at least retrieve the data and show us the HTML of that page. So you'll see that the program is organized using the exact same pattern, right? We are going to set up the SPI connection to the device so we can talk to the Wi-Fi adapter on the microcontroller. We're going to connect to the access point, the same as what we did before. And now we're going to do a loop. First, we're going to read from the connection to, what does that do? So read connection is going to actually try to communicate with the network itself. And then if it's been more than 10 seconds since our last request, we're going to make an HTTP request, which what that does here is this is actually creating the HTTP connection to the IP address of the server. And it's using the same interface as you would normally use for any Go program, whether you wrote it on the server or you wrote it on your microcontroller. It's not using the same net package that is part of Go itself. Instead, it's using a version of the driver's net package, which has the same interface, but a different implementation, one that does not require an operating system. That way we can run bare metal on these microcontrollers. So it's going to send the HTTP request, and then it will wait to see if it gets a response. Okay, right, so let's go and open up our code in our driver's repo, and we'll go over to the web client, and I will switch over to the main camera so I can pretend like we are very secure. And then we'll go back over to try to flash this. So now, this time, drivers 3, we're going to flash the Wi-Fi Nina program that is the web client. And so it should compile. You'll see it's flashing, does a little blinking. And then now if we go over to looking at our serial output, it connects to the SSID for the access point, same as before. Oh, maybe I mistyped again. That's pretty funny. I can copy and paste from the other program. That will surely work, right? I know there's a better way to do this. I actually set that up last time using not last time, a couple of episodes ago, using the ability to pass in from the command line a predefined value, which is going to be overwritten in the memory of your program. So it's just an easier way to do this same sort of thing. That way we don't have to go into the file and modify it. So we'll go and we'll flash it again. This time with hopefully the correct information because I copied and pasted. And then we'll go back to our trying to connect. And it's trying to connect to the hack space. And it connected. So now it's making a HTTP request. You can see that it is redirecting because Netlify is going to redirect from that location to the HTTPS version of the site, not just the unsecure. And so after that redirect has basically been ignored by our program, it will do the same thing again, send another request, and it should get the same exact response, right? Because we didn't write the code to follow the redirect the way that, any normal web browser type would. So you can see that also works. So let's look at a third example, just so we can kind of get a complete picture of the sort of capabilities that you can do. And this time, though, let's actually switch to a different device. So I really like this Arduino Nano 33, but there's some other devices which also have the capabilities which are built in to having an ESP32 coprocessor connected to some kind of main microcontroller. So this is a board from Adafruit. It's called the PyPortal. And let me see if I can get a little better view. There we go. So the PyPortal is a very cool board. It has an Atmel ATSAM-D51 processor, which is a lot more powerful. And it has a built-in display, color display. So we can actually, do some interesting things with it as far as displaying the information that we retrieve on the board. But right now, let's just try to make it work the same as what we were doing with the other example, which is let's just try to make it connect to an access point. And in fact, if I go to the code that we flashed before, right, we can go back to the original connect code. So if I go and I flash the connect code, and I just change the target, right? So instead of saying target Arduino Nano 33, I'm going to say target is PyPortal, which is the name of this other board. And otherwise, we're just going to do the exact same thing that we did. So this should be interesting. So it uses a different technique for flashing. Instead of using the Bossack bootloader, it uses a different bootloader called UF2. So we just flashed it, and we can go to, let's see if it's able to connect. And you'll see it's trying to connect to Hackspace. And it connected, and you'll see it has a different IP address and a different MAC address because, in fact, it's a different device, right? This is the Wi-Fi chip that's built into the PyPortal, not the Wi-Fi chip that was built in to the other board, the Arduino Nano 33 IoT. So same code, just compiled for a different target, different hardware, but it still works, right? So I'm kind of getting the idea of this. I'm going to grab my water. So this is the real Internet of Things, my friends. You need internet and you need a thing. Well, here you go. You've got internet and you've got a thing. Where are we going to go today? So thirsty. All right. Well, so it might be interesting. I don't think I'm going to do it this time because I actually had something else I wanted to get into. But yeah, it's a very, very cool set of things that we can do with all these different hardware devices with built-in Wi-Fi capabilities. And because of the Wi-Fi NINA firmware, or the NINA FW firmware, we're able to use this Wi-Fi NINA protocol, and we can communicate with really quite a different, wide variety of different hardware that has this built in. So it's pretty neat. All right. So I wanted to talk about something else, actually, which is I wanted to talk about my challenge that I issued last time to my friends at Bedrock for automated cow detection. So here we are in Asturias, and if we type in Asturias, and we say cow, Asturias cows. So Asturias mountain cattle is what the Wikipedia page offers. Not to be confused with Asturian Valley cattle. Okay, I'm already learning things that I myself did not know about, as they're known here, La Vaca Asturiana or La Vaquina. So they're very, very sweet and wonderful creatures. And it would be nice to be able to zoom into this area and auto-identify them. And that was the challenge that I was playing around with. So it turns out that GoCV already had some of the code that you might need to do this sort of thing in the form of a tracker to do DNN detection. So what is this DNN detection thing that we're talking about? So deep neural network detection, let's see if we can find it's using this, let's see if I can find it. Actually, single shot detector. Yeah, here we go. This was the illustration I was looking for. So it's a type of deep neural network that is very efficient at both identifying and also tracking. So the difference is we can have identifiers that do things like classification, and then we can have trackers that say there's a thing here within the image. But it's very hard to actually do both of those. And so the single shot detector is a kind of neural network that's specifically designed to be able to do both of these things, right? So it turns out that there is a cafe model that's already been trained to do exactly this, to detect faces. This is not the repo I was looking for. Anyway, it's a cafe model that's already been pre-trained. And let's see if we can find the original one. Here. Yeah, this is it. All right. No, that's not it. It looks like it should be it. That was not the repo I was looking for. Wait, actually it was in the code. Here we go. All right, so if we look at this, it's a face detector. And so we can download and use this model in order to identify faces using GoCV. So GoCV is a Go wrapper around OpenCV, and it's actually OpenCV that has the capability to load in cafe models, TensorFlow models, Torch models, or DarkNet models, and then use those in order to execute the model by passing through the data that it captures from the video camera. So we should probably take a look at the hello world of video first before we get into a slightly more complex, because we have just enough time to do this, I believe. So I'm going to use my latest version of Go, which is Go 1.16.3, and I'm going to go into my GoCV developer directory. And so now, if I say Go run, and I run the command for hello, I believe that will do it. That will compile this program in GoCV. Well, actually, it's a pretty simple one, but let's look at it first. So the hello world of video, what it does is it has a package main like any Go program. It imports, in this case, the GoCV package, and then it has a main program. So first we open the webcam on device 0, which would be the first camera on your system. We'll open the new window. Oh, wait, there's the window now. And then we'll create an image called a mat, which is a storage place for us to store each frame of the image as they're coming in. And then we will repeat forever. We first read the webcam into that image. We show it in the window. And then we give the user a chance to, press a key or something that way if we want to stop what we're doing. And so this is that program running using my built-in camera on my computer. Okay? So far so good. So I'm going to exit that program. All right. So now let's go back to the SSD program, now that we have sort of a basic idea of the way these things work. Okay. So now this program is a little more complex, but not too much. It's got the same pattern, which is first we initialize everything that we need. In this case, we're going to try to use let's just skip over this part about which hardware processing to use, whether we want to use the GPU or the CPU or whatever to do the deep neural network processing. Let's just kind of, skip over that for the moment because it's not too important, right? Suffice to say it works on either. So then we do the same thing as what we did before. We open the video camera and we're going to display it into a window. So we have to create that window and place an image. But then the difference here is we're going to actually then open our deep neural network object tracking model. We're going to read in the deep neural network, and what is this model? We passed it in as a parameter. That way we can use different models. When we actually tell you this in the instructions here, right? That you can specify which, if you want to, it works with both TensorFlow and with Caffe, as long as you use one of these SSDs that's able to do facial tracking and recognition, right? So, where were we? Oh, yes. So we'll read in the neural network, and then we'll just tell it to use whatever hardware we have available. And then we have to make a few little changes depending on whether we're using the Caffe model or the TensorFlow model, just as far as the scaling of the image, the colors of the image, the normalizing of the colors in the image. And then we have our same for loop as what we saw in our Hello World example. We read in the image from the webcam. But now we do something a little tiny bit different. So we take that image, and now we use a function that's built into OpenCV and consequently into GoCV called blob from image. So when we're going to process through a deep neural network, generally the data is organized. The actual data in the image is organized differently than the data in a normal image that you would just display on your computer. Specifically, the pixels from one of these blobs, you'll have all the reds all together, and then you'll have all of the greens all together, and then you'll have all the blues all together. A normal pixel will have the red, green, and blue, then go to the next pixel, and the red, green, and blue, and so on. So a blob actually separates these out entirely into separate blobs or chunks of data. And so this is just a function that's built into OpenCV, and we have a GoCV wrapper to make it easy to do that, because that's such a common procedure that you follow, is converting your image data into whatever format your deep neural network can process. So then we'll feed that input into the detector. We're saying that blob, we're going to set it as the input, and then we'll run a forward pass to the network, which is basically telling the deep neural network, go and do your work and prepare your results. And that's what this perform detection function here. Perform detection takes those results and then does a little bit of massage to decide, is it confident enough that this is actually a face? And if it is, get the tracking box and then use the GoCV rectangle function to actually draw a rectangle around my face or whoever else's face, right? And then once you perform the detection, we display that, and then we loop again to the next image. So we just keep looking at the camera over and over. So now I should be able to run this. If I say go, let's see if I can, Let's see if my bash history has it. Go run command. What was the name of it? DNN detection. No, it's not in there. All right, we'll have to fight our way through the commands. So it's command, and then it's DNN detection, and then we're going to need to give it some parameters, right? So the first parameter is what is the video source, which is going to be just 0, because that's camera 0 is my built-in camera. And then the second parameter is which model file to use, which we're going to use this cafe model, which I happen to have in my downloads. So if I say downloads, what was the name of the file? Res10. There's the cafe model. All right, and then we're going to say the config file. So the model file is the actual model itself. The config file describes how is that model organized. That way, if a program needs to process that, to do something, to decide how does it need to massage the data to pass it in, or how does it need to massage the resulting data into something useful. So then we're going to use the deploy.prototext is the name of that. That's also in my downloads file. And then I think we can now specify the back end and the device, which is if we had some special hardware acceleration, we could use that. But we don't need to. This should be everything we need right now to, wait. Oh. We need to say, I have to give it a build tag, which is to say, in order to prevent this from getting built automatically every time that the GoCV repository is tested, we have to say tag equals example. Oh, tags. Here's it, tags. Oh, I know why. It comes after the command, not before. No, that wasn't it. Is it example? I thought it was tag example. I forget how to do this. Let's see. Get help. Go help run. Or go run help. There we go. Go run help. No. Go. Yeah. Let's go help run. Let's see. Build flags. Oh, okay. So it should be. Well, it should have been after run, but before the rest of those commands. So we say tag example. No. I thought it was tag. Well, I'm already bored of that, so let's just remove that from the... Here, we can just... Actually, the easiest way to do this, we can just open our code editor and just remove that one line for now. So we'll go into our commands, and we'll go into our DNN detection, and we go into our program, and we'll just remove this, because I don't know why it's not working right now. I just have some syntax problem that I can't be bothered to look at. All right, so let's get rid of the tag example. And, let's see. Build constraints, exclude, all Go files and DNN detection. That should have worked. There we go. All right, so here we can see that here I am and it recognizes me, and it recognizes this gopher is not human. Whoa. And you can see that it actually works pretty well, regardless of my face angle, even if it's somewhat occluded, meaning blocked. I can't hide behind my gopher all night, or can I? And what's really cool about this, let's see if it can recognize me with a mask, first of all. It can. And let's see if can I have a human volunteer? Human volunteer in a mask.
In a mask, yeah.
In a mask, yes. Okay, so you have to stand next to me, and you can see that, yes, it's got no problems recognizing. No, I turn my head.
And I'm not even a normal human.
Exactly.
No, because of the and stuff.
Exactly.
The Irish bit.
No, it recognizes you as human. If the machine says you're human, you're human.
I'm human.
And so thank you. So one of the cool things about using a deep neural network for this kind of processing is it's really fast. It's just as quick to look for 2 faces or 5 faces as it is to look for 1 face, which is a very unique capability, very, very important when it comes to the computational efficiency of using deep neural networks. It is a very typical, as we would say, sort of S-curve. If you haven't, S-curve. An S-curve is a very typical S-curve, yes, is showing, in this case, it's trying to claim that it has to do with payoffs and time. That's maybe a bad example. But what it's really saying is that the initial computation that it requires gets really high fast, but then it doesn't require any more. So it's just as much work to track 1 face as it is maybe 50, just because of the fact that this is how the computation is designed. And I showed you that very briefly in this diagram here, that the single shot detector has this particular capability where it's able to both classify and track. Okay. So if my friends at Bedrock have been paying attention, I, in theory, have already given you everything you need to know in order to actually solve this challenge. And I know that they actually did write some code to that was able to do cow detection. I haven't seen it yet. I heard that it exists. I don't think it's written in Go yet, but I'm pretty sure that somebody retrained one of the, maybe even this very same single shot detector. They probably used a Caffe, or rather TensorFlow, because I know they do a lot of TensorFlow-oriented work. But basically taking and retraining one of these networks is a lot easier than starting from scratch. If you have a network that does most of what you need, you can retrain the final nodes to do basically the same thing, but with slightly different set of data. Now, this doesn't always work. Okay, that's not all there is to data science. Just retrain some network and, you're good. But that is a very good starting point, because certain categories of problems all fit into a particular set of solutions that work reasonably well. Actually, I was just discussing this with my son Manolo, who is currently studying computer science at a university in the United Kingdom, and he is studying artificial intelligence there. I prefer to call it humanized intelligence. That actually is a cool phrase I just learned today from, I forgot the researcher's name, absolutely brilliant researcher, really, really cool. Let's look up this. Here we go. So Ayana Howard, whose actual Twitter name is something like Robot Genius, or let's look at her name. Ayana Howard, American Roboticist. Yes, on Twitter. It's a really funny, clever Twitter. Robot Smarts, there we go. I wasn't smart enough to retain this. Anyway, she has just published this article that was very interesting, describing how for quite a number of years she's been using this term humanized intelligence instead of artificial intelligence. And I thought, I love that. That is so, but that's why she's a brilliant researcher and I'm just a person hacking on stuff. So I'm not ashamed to use the work of brilliant people and add it to my own collective intelligence. So anyway, humanized intelligence, I think, is a great way to look at this. It really appealed to me immediately, especially her description of how it put the human at the center. Also, there is no such thing as artificial intelligence. We only know one source of intelligence in the universe, and it is us. So maybe calling it synthetic intelligence or something, even though that in itself is a little bit closer, it's definitely not artificial. I can tell you that. But anyway, I thought it was a brilliant way of describing it and immediately adopted it as one of the terminology, catchphrases that I think it's very important for us to sort of spread out into the world, because the machines are not going to solve our problems. It's up to us to do that. The machines can only amplify the things that we ourselves already are knowing how to do. So it's up to us to tell them to do something that betters the human condition, right? That's the end of my sermon for today. All right. Well, wow. So I expect next week to see some awesome Asturian mountain cattle, or maybe valley cattle. I did not know that there was a difference, and that could be extra credit. Not only do you classify, but you can identify whether it's de la montaña, I thought all of the cows were basically, de la montaña. So I don't know. I guess we'll find out when this classifier is able to not just identify that it is, and in fact, an Asturian cow, but also which part of Asturias, and maybe even the name, right? That would be really cool. So, wow, we went through a lot of stuff today. We did a lot of things. We're running out of time. What else did I have to tell you? I don't currently have my the Twitch comments didn't show up in my feed. So if you've been trying to tell me something, I'm sorry if I haven't been ignoring. I've been ignoring you just because I haven't seen it. So I guess I'll go later. But yeah, we did a lot of stuff today. We took a look at some of the cool new features of TinyGo. Actually, we didn't get that into those, but we just took a look at the website, and that's where most of them are listed. We did some discovery of whether the current workshop for the Arduino Nano IoT 33 is working, as Lorenzo continues on his journey of learning to TinyGo. And then we took a look at the Wi-Fi capabilities, which are now fixed and working quite well, I must say, in TinyGo's latest release, both on Arduino and on Adafruit coprocessors. And we took a look at the classification problem, specifically cows, and how we could maybe use GoCV as one of the cool tools to do that. I mean, what I want a drone I can fly and in real time see this classification, right? You want that too, right? Okay, well, I think that's about it. Kind of wraps it up for this week. I thank you all so very much for coming. And GopherBot and I say to you, it has been awesome. It has been amazing. And we will see you next time. Same cow channel, same cow time, same studio, same place, different position in the universe. We love you, and Dead Program out.
Computer Liste, Computer Liste, everybody that it does get flat. Computer Liste, Computer Liste, Computer Liste, Computer Liste, everybody that it does get flat. Computer Liste, Computer Liste, Computer Liste, Computer Liste, everybody that it does get flat. Computer Liste, Computer Liste.